All right, everybody. So I want to welcome you back to the phenomenal and awesome Space Traffic Management Conference. Uh, we have this next session is SSA Technologies. I'm going to be moderating for you. We have a great cast of characters in this session. Uh, I'm hoping that everybody was able to, see their presentations and papers already prior to this, because this is mostly focused on questions and answers. However, one of the things that I'd like to do is just allow each person probably about 1 minute at most two to briefly kind of summarize their contribution and the importance of it to the session. And so I'm just going to read down the list of names. And again, please try to constrain it to about a minute to just summarize the importance of the work to the session. So we'll start with Alberto Águeda. You're muted.
Yeah.
Okay.
Hello. Thanks, Moriba. Thank you very much, Moriba. I'm happy to be here with all of you. So my name is Alberto Águeda. I work in GMV, managing in Madrid, Spain, managing the space situational awareness and space surveillance and tracking activities. So my presentation, my paper is about the efforts in performing Europe on space traffic management. In this respect, so ESA has done a quite relevant technology efforts in the last couple of decades on space situational awareness and space surveillance and tracking. And then the European Commission has done also a very relevant effort to come up with an operational system that somehow mimics the capabilities of the 18th Space Squadron in the US to provide collision avoidance services as well as other services for re-entry and fragmentation. And this system is composed by a set of national systems that are working on a federated manner in different European countries belonging to a predefined consortium composed by Germany, France, Italy, Spain, Poland, Romania, and Portugal. And from GMV, we are supporting most of these countries to develop these national capabilities on space surveillance and tracking in the frame of the USST. And then in the STM, in space traffic management, Europe is now trying to somehow push to develop some new rules of the orbit, some standards in order to allow the space traffic management be more sustainable in the future. And this is why there are a number of activities now ongoing. The main one is so-called a CSA on space traffic management to define these rules. And we, GMV, we are leading one of these consultations with also a number of experts across Europe. Thanks, Moriba.
All right. Thank you very much, Alberto. Ulpia.
Yes, hello. Good morning, good afternoon, everybody. Ulpia-Elena Botezatu, Romanian Space Agency. I'm a researcher in the Department of Space Situational Awareness. I'm also a representative to European Union Space Surveillance and Tracking Consortium in the steering committee and in the security committee as well. And I'm here basically to represent what Alberto was saying before, the Romanian SST system, just to exemplify what we did, what we are planning to do in the future. I'm not a technical person. There are some technical details in the draft article, which really has to be worked a lot. But anyways, I'm here to answer all the questions you have about it. Thank you.
Thank you so much. Han Sai.
Hello, everyone. Can you hear me? Hello, Moriba. Can you hear me?
Yeah. I can hear you faintly. Just use your outside voice.
Okay. Hello, everyone. My name is Han. Okay. I'm a postdoctor working with Moriba at UT Austin. In our paper, we propose a new method called credibility consensus fusion using order probability measures, namely OPMs. By using OPMs, we can achieve a truthful and more relaxed uncertainty representation, especially for those epistemic uncertainty that comes from the absence of information regarding some aspect of the system, for example, the imprecious measurement or imperfect dynamical models. And on top of that, we derive a general fusion formula that can be used in the OPM framework, and it has analytical solution. Based on this development, we propose a robust multi-source information fusion method. Um, Even if some data source may not have covariance or statistical information describing the accuracy, we can still achieve a consistent and reliable fusion. And we tested the method using some real orbit determination results from some data providers, including Planning Labs, Leo Labs, Dispoc, and our asteroid. And the test results suggest our method can achieve a stable and consistent fusion, and it has ability to account for the absence of information. Okay, that's all. Thank you.
Thank you very much, Han. Daniel.
Hey, thank you. My name is Daniel Kucharski. I'm a research associate at the University of Texas at Austin CAST group. My work is focused on satellite attitude, observation, analysis, and simulations based on optical and laser measurements, particularly focused on single photon detection. In this presentation, we propose Astrometric data engine that is structured on neural networks and will be capable of continuous learning and near real-time analysis and prediction. This will allow to make the best use of the available photometric big data for the near real-time brightness to attitude and attitude to brightness predictions. Thank you.
Thank you very much, Daniel. Let's go with Guido.
Yes, thank you. I'm Guido Pedone, I'm a PhD student in Airbus Defense and Space in Friedrichshafen, Germany. The topic of my PhD is about autonomous solutions for SST. In particular, I'm currently working on autonomous strategies for observation planning and or scheduling, and also to streamline all the operations that are between doing new observation and update the information of space objects inside a catalog. The paper I have presented for this conference is talks about the main software tool that we have here in Airbus and all the functions that are that complete the cataloging pipeline, and also some features that are connected, like object characterization and collision assessment. Additionally, we are also talking about our current activities with a robotic telescope in Spain, and that we fully control from Airbus in Germany. And that's it. Thank you.
Thank you very much. Apparently, we just got joined by Manuel. You got 1 minute to give us a summary of the contribution of your work, please.
Excuse me, can you hear me?
Yeah, barely.
Okay, I'm Manuel, and I would like to present a research done from a research team from the Division of Space Application at the Earth. Our research work is on improvement of space flight performance and optimal control using trained deep neural network trajectory controller for space object collision avoidance. So in our conference paper, we give details about our space mission called Deep Polar mission, and as well as how we are proceeding using the DNN algorithm for collision avoidance through trajectory optimization. Thank you.
All right, very, thank you. Let's go with Riley.
Hello, everyone. My name is Riley Steindl. I'm an outgoing master's student at MIT. I just finished my thesis under the advisement of Professor Daniel Wood, as well as Professor Jah. I presented my team's work, which is based roughly on my master's thesis, which was done developing the detectability, identifiability, and trackability analysis for the space sustainability rating, which is essentially developing a set of simulation tools that altogether assess how the design of the physical design of a satellite, as well as its orbital design, impact the ability of a generic observer on the ground to detect, identify, and track it. And while it was initially developed as just a tool for the space sustainability rating, we are also hoping that it can become a tool for just used in general for people hoping to better understand how their missions impact, or how the design of their missions impact space situational awareness efforts. Thank you, Moriba.
All right, thank you very much. And then we have Taseen.
Hello, Moriba. Thank you. I'm Taseen Tasif. I am a PhD student at the University of Central Florida in the Mechanical and Aerospace Engineering Department. I work with Dr. Tarek El-Gohari. My PhD research is on developing the perturbed orbit dynamics for using analytic continuation method. The paper we submitted in this conference, that is, we worked on the implementation of perturbed dynamics on orbit estimation using a new measurement model. Thank you.
All right, thank you. So I see that we have a very full audience of participants, except that apparently all these 95 participants are so shy that they haven't asked a single question. So I'm just going to step up there because, you know, as your session moderator, it is my responsibility to keep you on your toes. So I guess given all the variety of technologies that people have been working on here, I guess, you know, I'd like to, oh, okay, so we have one question here. It's for Daniel Kucharski. And the question is, do you think the Astrometric data engine has a potential application on other objects other than those in megaconstellations? Example, debris.
Thank you for the question. So this engine, this needs to learn on some example data set, and our intention is to train a data engine on photometric data of actively stabilized satellites, like satellites components of mega constellations, for example, or this can be also GPS or GNSS constellations. It has to be something that is actively stabilized during the learning phase of the process. And then this learned information can be used in the future to determine attitude of tumbling objects, of defunct objects that used to be stabilized, but became, for some reason, became defunct and still reside in orbit. So by learning on actively stabilized satellites and applying this knowledge to analyze defunct satellites, we should be able to do this brightness to attitude and attitude to brightness kind of conversion with active learning through this engine.
Thank you. Thank you for that. We have a provocative question here. I'm curious to see how people answer this. So when your various tools are predicting a conjunction between any two space objects, how can you best express the risk of the potential collision? Anybody? Don't be shy. Somebody's got to have an opinion about this.
This is Alberto. It's quite a tricky thing, to be honest, and because there are a number of services and which rely on different data, and Moriba is doing a lot of effort to to stress the fact that we need to have more knowledge about what is up there and more consciousness of what's up there, and because we can never be sure where something is, right? So indeed, it's quite a thing. So obviously we work on a number of algorithms that define a probability of collision depending on the source of the data that we count on, and these various algorithms are well, we always can provide different results depending on the source data. Then whether of course whether maneuvering or not is then is a decision that the operator needs to make based on the data it has at its hand. And in some cases, I agree that many operators as there are more and more services available, they count on several sources in order to basically be more, to be able to make a decision based on more and more information. But it's quite a tricky issue if the information provided by the different services is misleading, or it's, let's say, or do not follow, or is not, how to say, completely coherent. And in this case, there are so it's in the end, it's a decision to be made by the operator depending on the touch on how much it can trust the different services it uses. I know, Moriba, if you share this opinion.
Yeah, no, absolutely. And I think it's a great answer. And there's actually a follow-up question here that I think is very relevant to what you just said, Alberto, which is what are some of the key problems that people are currently encountering regarding the amount and quality of data available to feed through the tools? So as you said, Alberto, right? It's like the answer changes depending on the source of information that you put in. So one thing that I feel is a technology challenge for sure is how to provide a robust answer, given various information sources, quantity, quality, that sort of thing. So do people on this panel or session have ideas about how to try to mitigate these sorts of issues?
Yeah, and the fact on accuracy and uncertainty, right? So there's a big discussion about the accuracy of the data we use and the uncertainty of the data we use, and of course there's still a long way to walk on that subject, because there are a lot of sources of data which in some cases could end up being misleading. And in fact, that has been even the source of some of the issues that we had in the past on collisions on orbit and so on and so forth. So, and you know some examples, right?
Absolutely. Anybody else on the panel have opinions about this aside from Alberto? This is your moment. Yeah, okay.
Yeah, excuse me. So I would say that our mission is actually proposing to launch five spacecraft, but 3 of them will be in geosynchronous orbit, and those 3, each of them will be monitoring the atmosphere of Earth. So they will be covering 120 degree. So in total, they will be covering the whole atmosphere of Earth. Then the data collected from by those 3 spacecraft will be transmitted to other 2 spacecraft in low Earth orbit. And those 2 spacecraft, one of them will be achieving the collision avoidance. So through that way, yeah, this is our proposition from our mission, actually.
All right, thanks for your comment there. Anybody else? Let me put this out there to all of you. What are some methods that you feel could further enhance collaboration on these independent decentralized systems, right? I mean, everybody has their own kind of computational framework, algorithms, tools. So what ideas do people have in terms of enhancing collaboration between these independent systems?
If I may, can you hear me?
Absolutely.
What we were writing in the article, actually, it was something related to developing the same sort of common understanding, same sort of terminology, having the same sort of reference systems, because currently, as you were saying, and the others were saying, we have many, various perspectives, viewpoints. So I think one way of enhancing collaboration, international collaboration, would be through developing a common understanding.
Thank you for that. Anybody else have any opinions?
So I think our paper submitted to this conference is a related topic in terms of the collaboration on systems that are independent of each other, because we wanted to use a credibility consensus fusion to achieve agreement between different systems, different data sets in a distributed manner. This meaning that each organization can only exchange information with its partners, which is trust, and through several steps of communication, then each organization can have a um, improved accuracy of optical data estimation, and which comparable to a centralized data fusion. And our method can be a solution to this problem, considering some data sets may not have accurate statistical information describing their accuracy.
Thank you. Thank you for that. One type of question that's coming up here is, in the spirit of the theme of this conference, the trust but verify. Do people feel that the ability to trust information and that sort of stuff, is it a technical problem, or is it a non-technical problem, and to what extent do people feel that there are actual technical solutions to kind of enhance the trust of information?
Moriba, this is Alberto again. So there are two perspectives on this, I think. First, about trusting. You can keep start thinking about blockchain and this kind of technologies that define whether data can be trusted, whether data has not been corrupted on the way between the originator of the data and the consumer. And that's an issue that the European Space Agency is discussing at the moment, using this kind of technologies, mainly blockchain, for the exchange of data, so that we could have a completely distributed database. It would not be centralized at all, and you could trust that the data that is available somewhere, like the bitcoins, it could be the same that the originator created. And the second part is more related to the data itself, whether data can be trusted, whether it's accurate, and that's certainly an issue. And in order to get more confidence on the actual accuracy and uncertainty of the data, the best thing we see is having a lot of data, so that we could identify outliers. So the more data you have, the more sources of information, and then we could fuse all this data in order to identify what is the trend. So it's like the exercise that we do for GPS in the IGS, or in other communities like for laser ranging, right? So what you do is, in the end, you fuse a lot of data and identify when some of the sensors are biased with respect to a common reference created by all the rest. And when we fuse all this data, all the rest of sensors then follow the trend, right? And they all try to improve their performances. But in the current times, all this data is in most cases not very, let's say, or the level of share of data sharing is still too low, I would say, to achieve this.
No, I
know that you are doing a big effort on this.
No. Yeah. So I thank you for the answer. And the interesting thing is that there's a question that kind of follows up on that a little bit, and curious to see what you think, and certainly others here, is how do we manage? So like you said, the more data, the better, because you can kind of see the outliers and that sort of stuff. How do people approach managing large data sets? Do people have a methodology to prioritize data retention? So what do you curate? What do you keep? What do you get rid of? That sort of thing. Does anybody have I don't know, any ideas or any thoughts about how to manage these large data sets, how to curate these things? How do you prioritize what to keep and what to get rid of? Because there are storage kind of issues. I mean, storage is cheap these days, but a lot of people we tend to want to get rid of as much as we can, sort of thing.
Maybe I can say something about this because we have really hundreds of thousands of photometric data points to process. And this is usually just statistics. What is, I don't make any decisions by myself. I leave it to some Sigma filters and it's when some data is flagged as unreliable or corrupted, it still stays. It's separated from the main data set, but it stays there. And maybe this, bias or some sort of error in the data can be explained, in the future by some different kind of analysis. So we probably we don't want to delete any data. We will try to explain what the problem is with the outliers. But it's usually the filtering methods. This is all statistics, and of course having big data and large volume of data sets helps to filter out the outliers and manage the correct information.
Thanks for that answer, Daniel. One interesting question here is, it came up yesterday that, organizations like the Office, excuse me, the Office of Space Commerce is going to have to, provide, this open architecture data repository to provide, value added to the community. People right now access things like spacetrack.org. What is spacetrack.org missing? Like, what do people feel, hey, it's just not enough information or the right type of information? What would the right type of information from something like this look like? If it's not TLEs or state vectors, like, what do people feel is important to provide and share that is currently not being provided or shared? I can start by saying attitude, orientation, and characterization of objects, but I'd like to hear what other people have to say.
Well, but there's many things before that, Moriba. So we at GMV, we run our own collision avoidance services based on the data that the space track provides for the 18th Space Squadron. And so it would be excellent to first have access to the accurate orbits with better timeliness, so more often, or as soon as they are updated by them, and even if possible, have access to the source data. So if they could provide us with the source data so that we could analyze the data and be able to come up with even better orbits and do our own computations, that would be excellent. Then in the second derivative trade, indeed, I agree that having this information on object characterization and attitude motion, that would be very, very interesting. At least to have light curves from the telescopes they use, or RCS information from the radars, that would obviously be very, very interesting. But I see that that will take a while. I would say. What do you?
No, absolutely. Thank you for that. So it's definitely sensor measurements. Like, if you could get sensor measurements, that would be excellent. Anybody else?
Yeah, Moriba, I'd like to just second what you said about having the characteristic data, because I think, especially in relation to the work that our team is doing, having accurate, or at least semi-accurate characteristic data and just estimates for objects is really helpful in this SSA modeling efforts. In that, currently, I think one of the only large-scale databases is DISCOS, operated by ESA. But it'd be useful to have a database where the TLE and orbital information, as well as the characteristic information, are kind of integrated, so that it's a bit easier to manage that data on a larger scale and potentially look at trends across large quantities of objects.
Excellent. Thanks for that. Since we're kind of at the end of the Q&A here, I want to open it up. Is there something that I have not asked you that you feel that maybe you should have been asked that you'd like to just put out there before we close the session? Anybody? Don't be shy.
Maybe just to say that we are available. I put our email address in the presentation. So for whoever wants to discuss further or has questions or whatever, we are here. So looking forward to that. And thank you.
Thank you, Ulpia. Anyone else?
I would like to say that in this research, we presented one part of our mission, but the second part is focused on the space debris removal. So we will be glad to discuss further about that as well. Thank you.
All right, thank you. Excellent. So with that, I'm going to bring this session to a close right on time, as I like to keep it. And what we're going to do, I'm going to thank all of the session participants. Great exchange. In fact, it seems like the number of questions has grown exponentially. So if you want, you can look at your Q&A and feel free to answer these on your own. We're going to take a 10-minute break, and Matt Bold will be with you from Lockheed, moderating our roundtable on we're going to get into data quality, trust, all these things. What are the different dimensions of data quality? Precision, accuracy, like all these things. That's what the next roundtable is going to be about, how to trust information and that sort of thing. So I think it's going to be quite lively, and I'll see you here in 10 minutes. Thank you so much.